In this video, I'm going to introduce you to parametric modeling with Fusion 360. First of all, what is this parametric modeling? The commonly used definition for that would be using the computer to design objects by modeling their components with real-world behaviors and attributes. What that basically means is you are explaining a model with its parameters. So parameters basically the features of a model that can be explained with mathematical algorithms. Things like the size with dimensions and also the shape of an object. Anything you design with parametric modeling techniques will have greater level of precision because it has clearly defined shapes and dimensions, and that can prevent many errors can come in during the design and manufacturing processes. Rather than I'm showing you examples of parametric modeling, I thought it would be better to show what is not a parametric modeling. What you're looking at here is a car body design at its very early stage. This stage is basically made up with some organic shapes. So this is done by industrial designers, not engineers, industrial designers. So their main goal is ensuring this car design is aesthetically pleasing, and maybe it got some aerodynamic shapes and features. So when you look at this model, there's no way you can explain the curvatures or quantifying these curvatures of these fender lines because that is not done by measured values. It's not parametric. So when the next stage of this car shell would be handing over to the engineering department. When it comes to that level, the mechanical, product design, and manufacturing engineers of the organization will break this down into multiple hundreds of individual components and develop parametric models of each and every component so they can perform some simulations for loading and the strength ensuring purposes and also manufacturing them. This is an example of a parametric design. Actually, this is my capstone project to design and develop a semi-autonomous mini excavator for a competition held by NASA. This was a group project done with another group of engineers. Every single component of this design made with clearly defined parameters. Example, if you look at the bottom right picture, this is one of the wheel motor mounts that we designed with SolidWorks. Each and every feature of this part, such as these semicircular cuts, these holes, and these other complex shapes, they all have clearly defined dimensions that can be quantified and communicated clearly for a manufacturer. The accuracy comes with parametric design plays a critical role when you design a functional and complex products like this. This is how the final product look like with all the mechanical and electronics component in it, and it's nicely manufactured. And the right side picture is when it's in action in the NASA Lunar Buddy competition. If you guys like to know more about that, just give a Google NASA Lunar Buddy. So basically in this competition, the robot need to go through an obstacle course and collect some material, the soil, and come back and dump it there. So this was a international competition back then, and that was a great experience. That was a good design and development knowledge we gathered, the whole lot of it. I can't explain in words the satisfaction. Some concepts you had in mind came through a CAD model and it came to realization, and it's doing the job what it designed for. That's an awesome experience. I hope you will experience that in some level when you in the process of completing your design project. All right, so let's get into Fusion and get some hands-on experience on parametric design. Okay, now we're in Fusion 360 and we are looking at the design workspace. The rest of this video we'll be talking about sketching. Why is that? When it comes to parametric modeling, parametric design, sketching plays a very important role. That's in any kind of parametric CAD system. A sketch is where we draw the foundation or the base of the geometry that we are going to create. For example, I go to sketch here and pick a plane and just let's draw a normal rectangle, and there's a circle inside the rectangle, and finish sketch. Now it just basically it's a rectangle and a circle. Now I go right click and press pull. Now that becomes a box. It's a 3D object now. So box, and I have a cylindrical hole inside there. And also inside the sketch we can establish geometric relationships. I'll show another example of that. Click on the sketch, pick another plane, and let's draw a couple of lines. I'll go in detail about this later on, and maybe a 3-point arc, something like that. So geometric relationships, basically we call them constraints in this sketching language. So you can see there's constraints panel up here. So it allows us to select individual geometric elements and make the relationships among them. So right now the line what I'm having my mouse pointer and the other one, they are in a one random angle because I didn't specify any of the angles when I was drawing them. So even after I draw them, I can just simply go into perpendicular. Notice after I clicked on that, the mouse pointer changed according to the constraint I selected. Now it's a T, letter T in a weird angle. I can click on one line and the other line. There you go. They are in a 90-degree angle now. Even if I try to move them, they are maintaining their relationships. And here, this arc and this line, I want them to be in a tangential relationship. Then I got the tangent constraint. I click on the arc and the line. There you go. So now they're in tangent. So that is what I was talking about, establishing geometric relationships. So let's go a bit detail on drawing sketches now. You can follow along with me. Let me start a new one here. I'll finish this one and start a new drawing. Close it, don't save. Okay, so let's start a new sketch here. I click on this create sketch button. Now it's asking where do you want to draw this sketch. I got 3 options of planes. So the sketches can be drawn either on any of these planes or any of the faces. So I don't have any solid model in this drawing. So don't have any faces to draw on. So these planes, I need to pick one of them. So namingly, these faces, they are corresponding to the view cube. Right now, this one is the front plane, and this will be the top plane because that's corresponding to that top view of the view cube, and this is the right plane. So I'll pick the front plane for now. Then it is, you may have noticed the Fusion just reoriented that view, so it's perpendicular to me. As we call it a normal view. In case that is not in a normal view, just rotate it like that. You can, in the sketch palette, there's a button called look at. When you click on that, the canvas is reoriented to be normal to you. It's perpendicular to you. Okay. All right. So let's go ahead and draw some lines and see how it looks. Okay. So the good habit, a convention I would like to encourage is when you start with your first element you're going to draw, start with the origin. Okay, so one thing you notice, as soon as I click on the line button here, activate the line command, my mouse pointer changed. There's a little mouse pointer, and also there's a little line symbol, the same button, the symbol as the button attached to that. It gives an indication I have activated a command. Now when you click anywhere, you are placing that shape inside in this canvas. So now you can see it's just snapping to these grid points. You can turn on and off this grid, snap to grid. uh, yeah, okay. So when I turn that off, now you don't see that green the blue box anymore. Let me have that on for now. Snap to grid, turn on. Okay, so let's start with the origin here. I click on that. How it works is click to click, you are drawing a line. And I have turned on the chain line option. That means I can go click, 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 and we have a chain of lines. But before I go into that, notice there are some values changing dynamically. The first thing is the length, you can see, and the angle. There's another look at where the horizontal axis, the number 50 at. You can see there's another symbol, the light blue color one. So that is the automatically detected constraint. What is that constraint? Horizontal constraint. So it just snapped to this, snap in the sense just like a magnet. It just, when I move the mouse pointer down, it just uh, getting attached to that horizontal axis for a second until I move the mouse pointer down. So horizontal constraints automatically detected. So when I click on that, click anywhere, so that constraint is already placed. Now I can just click, 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 click. I can keep clicking. When you're doing that, you can see there's some other lines appear. Notice when I'm in this position, the parallel constraint appeared. If you can see this, notice where this tick mark at. There's another blue markers like two tilted lines like backspaces. So they are the constraints of this parallel constraint. So it found that the line I have already created here, this line, and the new line is parallel to that. So it's dynamically showing me the constraints and giving me the option to click there to maintain those relationships. And also there's another blue dotted line appears there. We call them inferences. So if it shows me that if you click here in this horizontal line, those 2 points are going to be in horizontal line. And let me go ahead and complete this line by simply just clicking on the origin. Now notice the color difference. As soon as I click on that, this shape, whatever that is, came into a light blue shade. That indicates that that's a closed loop. Okay, so what does that mean is basically it's ready to be converted into a solid shape. We'll come to that eventually. So if you look at my mouse pointer, I'm still in the line command, still active. If you want to get out of that, just simply press the escape key in your keyboard. Okay, all right. So if you look at this, there are some symbols there. One you already knew happened before when in the operation of drawing this shape. This is a horizontal constraint, and this I explained that before, right somewhere here when I was drawing. That's a parallel constraint. That means these two lines, this one, two, they are in a parallel constraint. If I place my mouse pointer here and try to move up and down, it's just maintaining that relationship. If I try to, so if you move your mouse pointer, you can see little dots appear. You can try to move the shape. It can move, but still it will not violate the constraint you already placed here. Okay, so example, Okay, so let's go place some other constraints here. Horizontal and vertical. So they are giving a one single button here. What it does, it just activate the uh, constraint that the closest one. Right now, this line, it's more towards the 90-degree. So when I click on that, it is going to be a vertical constraint like that. How about this one? This is more like towards the, if I say this x-axis and y-axis, it's more towards the x-axis. If I click on this, it's going to be a horizontal one. Without going horizontal, let me, okay, so that's fine, leave it there. And if I like to make these two lines are perpendicular to each other, I can just simply go perpendicular constraint, click and click. There you go, done. I can do the same thing here, click and click. So notice I didn't have any uh, uh, constraint for this line. So therefore it just kept my first clicked line stationary and fulfilled that constraint requirement, just changing the other one. Now what I can do, what if I make this line and this one parallel? Oh, yeah, parallel. I can do that parallel. Click here, click on this line and this line. Oops. So that went parallel, but notice what happened. It just went to just drastically change my shape here because it just trying to balance, trying to fulfill two, three requirements together. So let me move them up. I can still do that. There you go. So there's still a big variability. I can move things around here and there, no problem at all. Okay, so let's make this one, this shape, these two are parallel. Uh, this one and this one. Boom, done. Okay, so now I think all of them are constrained now, but they are still very loose. Why is that? You can still change the uh, positions like that because I don't have the dimensions here. So I got the shape very roughly, but not the dimensions here. So dimensions is another very important item when it comes to parametric design. Let's go ahead and place some dimensions in here. And when I'm doing that, notice the color changes here. Okay, so right now I have this line black, this line black, the others are blue. So that means they are not uh, dimensioned at all. They are not fully constrained. Even though I have this some relationships made here, they are not fully constrained. So dimensions are done through this button here. Okay, or keyboard shortcut letter D, press letter D. And if you had a line selected when at the time you press it, then immediately it will go to dimension that line. So if there was a mistake, you can just simply press the escape key and escape again to deselect that line. Maybe like just escape 2-3 times, it won't hurt. Just to make sure you haven't selected any, just press escape a couple of times. Then without clicking any of this, click on the dimensions. Now you can click on the lines, individual lines to give dimensions for that line. So let's make it 170. Good. As soon as I press that 170, you can see some lines got the colors here. So let me click on this line here and make it 80. All right. And what if I told, so these two lines, the vertical lines are parallel. I can also make them equal as well. Equal this line and this line. This one and this one. There you go. So now they are equal. it won't let me change this shape because they are equal length. And you can see this constraint symbols here. And if you don't like them, always you can just click on them and delete. I'm not sure you noticed there was a little error popped up here saying overdefined. I mean, I have fully loaded that with constraint. I made them vertical, then also parallel, then also equal. There are so many constraints there, so it won't like it sometimes. Example here. So right now I have this horizontal line, this vertical line. They are in an perpendicular relationship. What if I go to dimension and try to give a dimension to them? Click and click. So notice if I want to give an angular dimension, I just click one line, the other line. And when I let go, click, it's saying, it giving me a warning here, saying adding this dimension will over constrain the sketch. Choose OK to create a driven dimension. Okay, so what is a driven dimension? So that means it's just for reference purposes only. So it won't drive any of these numbers here. So if I right click on this, then you can change it to toggle driving. Notice as soon as I click on this toggle driving, I have an error saying the sketch geometry is over constrained. Why is that? Because I have this perpendicular relationship and also the 90-degree. I can toggle it if I delete this one. Let's go ahead, click on this perpendicular and delete it. Now this is still driven. I need to right click and make it toggle driving. Now I can click on this and change it to a different number. Let's say 120. There you go. I can change it to a different number now. Okay. Alright, so is it fully constrained? No, still not, because I can still change. So if it fully constrained, all these lines should be in black color. So why they are not fully constrained? Okay, the angles are missing, because I remember I deleted the vertical constraint. So let's go ahead and add that back again. Horizontal, vertical, I click on this line. There you go. So they are now mostly constrained here. Only thing not, which is this. Why? Because I don't have the lengths defined here. So and also it can go further down as well. So if we give dimensions for this line, both horizontally and vertically, that should do. So let me go ahead, this line and this line, I would say 45. And one last thing, I can give dimensions to this point. Click and origin. I'm happy with 55. Press enter. There you go. So now we have a fully constrained sketch here. So I have the dimensions and constraint that all placed in here. Okay, so that is how you create a fully constrained sketch. Once you're done with that, you can go finish sketch. Now it's ready to for extrusions or whatever the operations you want to do to make it a solid model. I can go right click, press pull. Okay, there you go, done. So there's a little bit more to cover in this sketching section, so I'll create another video on that, including how to set up an image to the background, so then you can use that as a template, as a stencil or canvas. So I'll do that include that for the second part of sketching video. Meanwhile, before you start that video, I would like you to try this exercise. So using the sketching knowledge you acquired in this video, I would like you to create these two sketches here. So they are fully defined. I have given all the dimensions. So the main advice I can give you is, first, do not worry about the dimensions. Don't just draw a line and give 140 to that, another line 25. Nope, not like that. Just draw the basic shape with the lines the same way I did in the video. After that, as a second stage, give the necessary constraints. After that, you can give the dimensions. So I got two drawings here, 1 and 2. The first one you should be totally fine looking at my the first video, you know, the same video. This one, there may be some new things, but try to read this constraint. Okay, that is tangent one, and there's a symmetry one. So I'll go through all this, and there's another concentric one. Try to, you know, just give it a go. See if you can figure it out and make this drawing before you look at the second video. In the second one, I'll go through all these things. I'll also provide the some clear pictures of this. So then you can have a look and try to replicate it. All right, so thank you very much. So I'll see you in the next one. Thank you. Bye.